is the solution. I'm wearing my little butterfly hat right here. To homework 6. Is this homework 6 already? That's good. Homework 6. My glasses are dirty, so I'm not clean them. Jeez, that's disgusting. What is that? Dog? How did I get on there? I don't even know what that is. Oh, I hope that isn't scratches. Those look like scratches. Oh, wow. This is already turned out to be a great video, isn't it? Well, it's coming off, alright. Whatever that was, man, a little concerning. Oh, still not great. Alright. So here's going to be problem 1. We have, let's see, what do we have? Force is applied to a pipe in the U-Hart basement equal to 75 pounds, and we get a angle psi right there of 25 degrees. The pipe's dimensions are 36, 24, and 40 degrees, and we want the reaction moment at O. We also want to have the equivalent moment at O using the cross product. So there's 2 different methods. I'm trying to make sure we can make this distinction about each one of these. Hopefully I won't cause confusion. So anyway, let me put the problem over here to the side in the other monitor, and so I'll stare off over in that direction. And let me put in, let's see, you need to see me writing. Okay. I don't think you need to, but Dr. Deal. This is my Spring 21 ES110, and this is homework 6 already. Problem 1. And let's take a look at this thing. Alright, so we have this little pipey thing you do. Looks something like that. Is that an angle? Kind of like that. Yeah, something like that. And here I'll draw the wall. There's the wall right over there at point O. And we have a force that's not in line with the pipe. It's at a different angle. Right in there. F. And that angle, didn't do a great job making that look right, is psi. And here we go. This is going to, oh, this has an angle too, so we're going to try to avoid that angle right in there when we make our dimensions. We'll make it extension line come up a little bit. And what is this? This is B. And this is A. Okay, there's a little pipe fitting right in there. And I'll write a given underneath it. Given A, what did we say first? Sorry, they gave us F was 75 pounds. Psi was 25 degrees. A is equal to 36 inches. B is 24 inches. And lead. Get the lead out. I know that I can hear some lead in there. So I know it's in there. Come on. Man, that is some seriously stubborn lead. That's a great video. There you go. I'll push some out. This one's stuck in there. Alright. And lastly, theta is equal to 40 degrees. We would do the find. I'll put it over here. Probably could be nice to organize this a little better. A, we want the reaction moment. Or at. People don't use that for at hardly anymore, do they? Well, I guess they do. At equivalent moment at O. Because it's using FBDs, using cross prod. All right. Okay, so in my first one, I want to draw my free body diagram onto this thing. So I'll write my FBD. And hopefully you guys will be already into the FBD, doing the FBD thing. All right. Here's our X and here's our Y. That's needed. All right. So I think the best approach for me, I'm going to use, is to break this thing into components. I won't even bother writing the F on there. I just want the components. It's going to have a reaction. It's actually, I'll draw the reactions. I didn't ask you for the reaction forces, but we should probably start doing that. You're going to have to do reaction forces and reaction moments, but we'll write them on here. Here's the reaction. This will be the ROY, and here's the ROX. And now I'm going to have a reaction moment in that direction. Now, one of the things, we didn't do it in any example, so let's see what happens with you guys, whether you'll be able to pick this up. This force is actually going to make a clockwise rotation. This force is going to make a counterclockwise rotation. So we don't necessarily know which way this moment at O, I'll call him MO right there, which way that's going to go. So I'm just going to draw him in the positive direction and hope for the best. I know, it's kind of funny. All right, so anyway. And for these dimensions right here, I think I'll put the dimension up here maybe. It's not there's no real good place for me because I wrote all my letters down here. Maybe I'll put it down over here, okay? So we're not doing any drafting. We're not drafts persons right now, so we can have like a little bit of a leeway here, but it would be nice if we had put this in there. In a place where we could actually organize it a little better. So let me write over to the side that fx is going to be my 75 times the cosine of 25 which then comes out to 67.97 pounds. And then Fy is going to be my 75 times the sine of 25. Which comes out to 31.70 pounds. Well, so let's see. I want this dimension right here, right? So that's going to be B times, so I might even, maybe I'll call this something. I'll call this like dy. Maybe I can call this dx right in there. So I'll say my dy is going to be equal to that 24 times the sine of my 40. All right. So that's going to be my 15.43 inches. And then my dx is going to be, it's going to be 36 plus my 24 times the cosine of 40. So 24, 40 cosine times 36 plus, and I get 54.39 inches right here. So I take the sum of the moments about O, it's going to be equal to 0. And so the reaction moment is going to be, okay, so I drew it as positive, so I'm just going to write this down. And by the way, sometimes it gets confused with students. They think that this is MO. This is a general MO, and this is the reaction MO, and they're just they're two different things, really. This is like and sometimes I think, well, maybe what I ought to write down is write like this, like RO or something, I don't know. But I think that would make it confusing. So I'm going to leave it as MO. But just be aware that, there could be other moments, even actual moments placed onto this thing. This is just the reaction moment, and this is the specific one. I don't know if I made that more confusing than it needed to be. But anyway, now I'm going to take, let me take this one first, right? So this one's going to be counterclockwise at FY. So at FY, we found it to be 31.70, and it's going to be multiplied by that dx, or 54.39. Okay, and then this other one, though, he's going clockwise, right? That fx is making it go clockwise, so he's negative, and he's 67.97, and it's times 15.43, and it equals 0, right? So I'm writing this whole equation down here, just like I'm like up here. I'm summing up all the things that are applied on there, including the reaction, and they should all balance out. So when I get done with this, I get an MO right there of, let me do this, 30, I could actually, I don't know, some of these things are still in the stack. Okay, so 31.70 multiply by that. Right, and that one's still in the stack, so 67 point, you can't read that anyway, so it doesn't matter. 97 times, and now I'm going to subtract, boom. Okay, so what I end up with is a negative number, because this one was more than that one. In fact, if let me look at these just to compare. Might be a nice thing to do. What I'm saying when I'm done with this, by the way, is I say that I get 675.4 inch-pounds is what the answer is. But my 31.7 and my 54 point, I can't read that now, 39, they come out to 1,724. Whereas my 67.97 times my 15.43 came out to 1,049, right? So this was larger than this, and this was positive. It went back on the other side, and I got a negative answer. So my actual answer here, according to this, is 675.4 inch-pounds clockwise. Right? Because I assumed counterclockwise. So that's what I got right here. Now that's part A. Part B now, right? And I could even, maybe I'll even, I'm not posting this. I'm just making this for my own. But I'll go ahead and box that in. I like boxing things at the very end, generally speaking. But here you go. There's the solution right there. But now let's do it using cross products. And so what we're going to find is the equivalent moment. This is the equivalent moment right here. The equivalent moment is going to be R. And let's see. This, I didn't write down what the points were, but maybe I should have. I didn't call them anything. Let me call this A. Let me call this B. Right? Up above. Right? So I call that A and that B. So the position vector, and I should have, that was a mistake, but it's okay, maybe you guys will figure it out. The position vector that I want to get about O, I need to go B with respect to O, right? So B with respect to O, and cross it with the force that I got, right? So now I need to create these two vectors to be able to do those from the information available here. So, and I actually kind of have that right here. Like I could write out that my RB with respect to O is going to be this distance, this whole distance up here, from here to up here in the x direction, which I already found out was 54.39 I. And then the vertical distance, right? So the vertical distance between there, which I found was 15.43 J. And these are inches. Now the force is going to be, already broke it down, right? 67.97 in the x direction, 67.97 I plus 31.70 in the j direction, and these are pounds. So I set this thing up as the determinant I, j, and k of this, and now the position vector goes across, so the position vector is 54.39 and 15.43 and 0, and then 67.97 is the force vector, and 31.70, and there's zeros in the k's, right? And now I'm going to take, okay, so I can do this. Maybe I should go ahead and work it through here. I take the determinant of this little square right here times I, right? So that little square is going to be 15.43 times 0 minus 0 times 30. Let's see, I wrote that. It looks like I wrote 31.70, right? And so that's I. And now I do the same thing here for J, but I'm going to use those two columns as a 2 by 2, right? So I say minus, remember, but it's not going to matter. 54.39 times 0, and then 0 times 0. I said it weird, didn't I? 97J. All right, and I'm not done here. So all those are going to be 0. So now I go down to this last one, plus I'm going to take this and go to the determinant of this one right here, right? So I say I have 54.39 and 31.70 minus my 15.43 to my 67.97 K, right? And if I work all those out, right, that all goes to 0, that all goes to 0, and so all that's left is a 54.39 and 31.7 multiplied. I get my 1724, like I expected back up there, right? And then minus my 1543, 67.97 times, right? And now I subtract them, and I get a positive 675.4 inch-pounds. Now what I'm going to know here is that this one is positive, and by right-hand rule, that means that's counterclockwise. So this one is opposite of that one, and you're like, oh, how come? Because this one is the reaction, whereas this one is an equivalent moment. This one is essentially saying that we've moved this force to down over here. What is the, and we're going to see that with couples, we're going to reinforce that with couples, that this force right here moved over to there. If we wanted to say, okay, what is the equivalence of this force? It would be moving this force over to here plus that moment, right? And I don't think we've actually described it that way though yet. So the answer to this one, really, I'm going to keep it as a vector, and I should have left this right here. Actually, you know what? I don't need to rewrite this thing. I'm just going to box it because that's correct. Put the unit vector in there, and also put the units, right? So they're inch-pounds, and that's ta-da, enough information for this problem. I do like to write answers, kind of like all together at the end, but it's the reason why we box them anyways. It's just to be able to find them. So here we go. ta-da! And that's problem one. And I wore like these funny little things here while doing it, just to see if that would amuse anyone. And it took 20 minutes to solve this problem. Hope it take you less. Hope so.